in this last part of our tutorial on Swift's functions, we will be discussing function type and nested functions. Like other parameters in Swift, where a parameter is associated with a type, functions also have a type. The type of the function is defined by the types of its input parameters and its return parameters. For instance, in the case of this example, where we have two inputs, one of type string and the other of type int, and a return value, a single return value of type double, the function type is shown like this, where it says that we have a function whose input types are string and integer, and the output type is double. For a scenario like this, where we don't have any input parameters or return parameters, the type is shown like this, where we are saying that this function has no input and the output type is of type void. We might recall that void is synonymous to a tuple without any values. In the same way that we can have parameters of the familiar fundamental types, we could also have parameters whose type is a function type. For instance, for this function definition, the function type is given here. There we are also saying that we have a variable called a function whose type is given by this. Ordinarily, in the case of fundamental data types, we would have had something like var or let, following by the parameter name, colon, and the data type, something like integer, float, double, string, or other types. In this case, we have a similar format. We are saying that this variable is effectively a function whose type is given by this. This is declaration alone. We are not assigning anything to this. Similarly, we could have simultaneous declaration and assignment for parameters whose type is a function type. For example, for this function definition, where we have no return type, but we have input parameters, the function type is given by this format, which is saying that this is the type of a function which takes two input values. The first is of type string and the second is of type integer, and it returns an empty tuple. An empty tuple is equivalent, or is another name for void. So for that reason, instead of showing the format like this, we could show it in this alternative format, and instead of the empty brackets, we could use the word void. So in the case of these two examples, we are saying that we have two variables, one called a function, the other one is called the second function, Both of them have the same type, but at the same time we are assigning some values to these parameters. To the first one, we are assigning another function called funcName2, which is the same as this, and because this has the same function type as this declaration, we can assign this to our parameter. Similarly, we could do the same thing with the second parameter. So in effect, what we are doing here is we are assigning the same function to both of these parameters, and we're turning both of these into functions as well. Similarly to the case of ordinary declarations, that we could use inference. In the case of function types, we could do the same thing. So for this function definition, we could use this declaration. Swift looks at this side of the equation and it sees a function name whose definition is given here. Looking at this function name, Swift determines the function type of this function and then assigns the same function type to a function. So it infers the type of this by looking at the type of this function. It should be noted that when we do this, we only use the name of the function. We do not put any parentheses in front of the function name. Once a parameter is declared as a function, we can call it in a similar fashion. Here, for instance, a function is declared to be of a function type. Then we could call this parameter, because it is a function, in this fashion. And in the same way as we would call funcName1 using these argument labels, we call a function using the same argument labels, and we pass the values to it accordingly. And this new function will return a value which is the same, which has the same type as the return value of the original function. Once a parameter of a function type is initialized, of course if it is a variable, not a constant, it can be set to a different function in a similar way that ordinary variables can be initialized and reassigned. In this example that I'm showing here, we are defining a variable called a function, which is of this function type, and then we are assigning a function called funcName to our parameter here. FuncName is defined like so, and if you compare the function type of this parameter with function type of this function, you notice they are the same. So in other words, when we are assigning a function to a parameter of a particular function type, we have to ensure that the function type of the function is the same as the function type of the parameter. This of course was true in case of fundamental data types as well. We could not, for instance, assign a value which is of a string type to a parameter which is of a double type. Now, here we showed the process of initialization. Now consider a second function called funcName2, which has the same function type as the first function, also the same function type as our parameter. Now, because the function types match, it is possible to reassign the value of this a function from its initial value to a new value, which is this new function, funcName2. In the same way that functions can take input parameters of fundamental data types, functions can also take input parameters of function type. For instance, we have a function here called funcName. It has two input parameters. The first input parameter in 1 is of type string, and the second input parameter in 2 is of a function type defined by this format. FuncName returns a single value which is of type double. When we calling this function, we can do it like this, where the first input parameter is a string. So we are passing a string to the function, and the second input parameter that we are passing is called some func, whatever that function is, as long as the function type of this is the same as the function type of funcName. This will be a successful function call, and as a result of this function call, a value is returned which is of type double and assigned to our variable called x here. Let's have a look at an example of the case where an input parameter of a function is another function. First, let's have a look at this simple function called f1, which has two input parameters in1, in2, both of type integer, and the f1 returns a value which is of type integer itself. Within the function, we have a variable declared by the name of x. It's of type integer and is assigned a value which is equal to the sum of the two input parameters in1 and in2. And the function returns x once x is evaluated. A second function called f2 has two input parameters in 3 and in 4. The first input parameter in 3 is of type integer, and the second input parameter in 4 is of function type, and the function type is of this format. Note that this format is the same as the function type of f1. f2 returns a value which is of type integer. The body of f2 includes a line of code which declares a local variable called x, which is of type integer, and it's assigned a value. That value is equal to the product of in3 and in4. In3 is of course just a simple integer. In4 is of function type, so as a result in4 itself is a function. So it accepts some input parameters. The input parameters will be of the same type as the format which is shown here. So these two will be integers. We do not show the argument labels for this because we do not know at the function call which function will be passed to f2. So any function which has a function type of this format can be used as an input to f2, and any function could have its own argument labels. So as a result, it's not possible to mention any argument labels here because it could differ from function to function. So all that is needed when we are using in4 is just pass the actual values without any argument labels. So once in3 and in4 are evaluated, they are multiplied together and the result is assigned to x, and x is returned by f2. Now let's look at the function call for f2. Here I'm calling f2 with two input parameters. I'm passing 4 for in3 and f1 for in4. 4 is just an integer which agrees with this type, which is the type of the first input of f2, and f1 is a function whose type agrees with this format. Of course, f1 is shown here as well, and that could be checked. So as a result of these input values, when we go inside f2, in3 will be replaced by 4 and in4 will be replaced by f1. So here we will be evaluating f1 for these two input values, and using this function definition, the return value of f1 will be calculated and multiplied by in3, which is equal to 4, and the result will be assigned to x, which will be returned by the next line of code. We just discussed a scenario where an input parameter of a function could be another function. Here we discuss a different scenario where the output parameter or the return value of a function can be another function. That is shown by this example, where we have a function called funcName. It has two input parameters, in1, in2, one of type string, the other one of type integer, and the return value of this function is of function type, and the format of the function type is given here. In other words, funcName will return another function. Now let's have a look at an example for that scenario. We start with the same function f1 as before. We also have a second function called f2, which is very similar to the above function. The only difference is that in the first case we add the two input parameters, here we multiply them. Then f3 is a third function which takes one input parameter in5, which is of type Boolean, and it returns a function. The type of that function is defined by this format, which is similar to the function type of f1 and f2. Within the body of f3, we don't do much. We only decide whether we should return f1 or f2 based on the value of in5. So if in5 is true, we return f1, otherwise we return f2. Notice again here that we're not specifying any input parameters for f1 and f2. So this function can return either of f1 or f2. Now let's have a look at the function call for this example. Here we are declaring a variable called myFunction, which is of the same function type as f1 and f2, and then we are assigning it a function called f3, which is this function, and we're passing f3 an input value which is equal to true. So what happens here is, because in5 is set to be equal to true, when we go inside the body of f3, in5 is true. As a result, f1 is returned by f3. So f3 here will return the function f1, which is then assigned to myFunction. Now if we declare another variable x, which is of type integer, and assign it a value which is the same as return value of myFunction for these two input values, we end up with a value of 12 for x. Notice here that we are not using any argument labels when we are calling myFunction. The reason for that is the ambiguity that we have to deal with. Here, for instance, when we call f3, we don't know which one of these functions are going to be returned by f3, and as a result we don't know whether we should use these set of argument labels or these set of argument labels, right? So as a result, when we're calling myFunction, we don't know what argument labels are supposed to be used. As a result, we only pass the values to myFunction, and the important thing is that those values have the correct types, and those types are provided by this function type. Nested functions is the last topic of our Swift's functions tutorial. A nested function is a function which is defined within the body of another function. The scope of a nested function is the body of the function within which the nested function is defined. We call this second function enclosing function. This means that a nested function is local to its enclosing function, which in turn means that a nested function can be called from within the enclosing function, and it cannot be called from outside the enclosing function. A nested function can call other nested functions which are defined within the body of the same enclosing function, and the functions defined within the body of our main code can be called from inside an enclosing function, as well as from inside the nested functions of that enclosing function. A nested function can be returned by the enclosing function to be accessed by the outside world. If the nested function is not returned by the enclosing function, it remains local to the enclosing function and it cannot be accessed by the outside world. All the functions that we've seen so far are known as global functions. These also can be considered as being nested functions, but they are nested within the larger function, which is our main code. Let's have a look at an example of nested functions. Here we have an enclosing function called encfunc, and within our enclosing function we're defining another function called nestfunc, short for nested function. Nested function is defined within our enclosing function, and it's local to our enclosing function. Nested function can be called from inside its enclosing function. This is what we're doing here. We are calling nestfunc using two input values, which are the input parameters in1 and in2 of enclosing function. Nestfunc then returns an integer value which is assigned to x, and then x is returned by the enclosing function. As I mentioned earlier, nestfunc, which is a nested function, has a scope which is the body of enclosing function. In other words, nestfunc is local to enclosing function, and as a result it cannot be accessed from outside of its enclosing function. So this line of code would be invalid, and it will cause an error. Of course, if we wish to access nestfunc from outside of its enclosing function, we should define the enclosing function so that it returns another function which is of the type of nestfunc, and then if enclosing function returns nestfunc, then nestfunc can become available to the outside world. Encfunc can be called similar to this. So we are passing two values, 100 and 300, to encfunc. Those two values are the values which are assigned to in1 and in2. Then within the body of encfunc, we use in1 and in2 as the inputs to nestfunc. Those two values are used within the body of nestfunc, and they are added together and returned by nestfunc. The return value is then assigned to x, and x is returned by encfunc. So the result of that will be assigned to q, and q will be equal to 400 for in1 equal to 100 and in2 equal to 300. This brings us to the end of our tutorial on Swift's functions.